Okay, Oscar, pay attention, because you might forget. This, we had our Alex topic that we've already copied and pasted into our notes. I am going to go ahead and show, and just copy our directions essentially for this kind of problem. There we are. And a little other note, just so it's a little bit more clear. I like to include what happens during these different types of reactions because the tag is just writing and balancing complex half reactions in basic solution. So because they give you both oxidation and reduction questions, you have to look out for the keywords that they're asking for. So writing balance half reaction, boom, you already know what problem it is. And then for the reduction here, this is the key giveaway. For the reduction of blah 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 to blah 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 in basic solutions. So these last two steps that I added in white over here, you'll see 5 and 6 are for basic solutions. Basic aqueous solutions. Okay? Now, this is going to be real simple once you get the hang of it. What are they asking for? Reduction, so we're just going to focus on the reduction part of these notes. So we could even remember. This is important because you'll know by the end of writing this whole balance half reaction out that if you have your electrons on the product side, you did something wrong because this is a reduction reaction. So therefore, reduction is gain. We're gonna gain somehow. We're gonna gain electrons to get our product, which you'll see in a little while. Um, and it's not very obvious, so usually you could do this one of two ways. So let's just start out by writing our reaction. So for most people, it might not be entirely obvious that what's going on is that you're going from essentially a 2 plus oxidation number to a neutral oxidation number. So you've gained 2 electrons on the product side, which you'll write out here on the reactant side. But this H2 gaseous has, because one, it's a diatomic, molecule. So somehow, if it's not sharing its electrons with oxygen and sharing it with itself, it has to have gained 2 electrons. But you'll see that in a bit. Like if we really want to write out the Lewis structures of this, just to show you guys what this looks like. This is going to be reduced. This is looks very simple, but the electrons here are being shared with oxygen. Those electrons are coming from oxygen because oxygen has 6 valence electrons. So you're gaining 2 electrons to make H2 gaseous because if not, these would both just have 1 electron, but they wouldn't combine in this diatomic form. So you have to have added 2 electrons. But we'll get to that later. Don't get too confused. Let's just put this at the bottom and put this on top. You'll see what I mean. in a bit. Let's move on with other directions. Let's change this to blue. We're gonna first balance out this. We're gonna first balance out our anything besides oxygen and hydrogen. Well, too bad, there's only oxygen and hydrogen. So what are we gonna balance first? We're gonna balance oxygen. We're gonna balance oxygen by adding waters. So here we have to add 1 water. Okay, cool. Now we have to balance out our hydrogens by adding hydronium. So here we have 4 hydroniums, or 4 and 2. So we have to add 2 more, not hydronium, sorry, hydrogen ions. Okay, and now we have to, so the fourth step is balance out our electrons. We've already did that by proving that this is being reduced. And now we have to go to step 5, which is neutralize our H pluses, our hydrogen ions, with by adding hydroxide ions. And you have to do this to both sides so as to not disrupt the equilibrium. So we're going to add 2 OH minuses on both sides. So now, what is this going to give you? That's going to give you 2 waters. So I'm going to write out just to make clear that this came from here. 2 H2Os liquid plus the original H2O liquid. This is the H2 gas plus H2O liquid. Okay. And finally our OH that we added to both sides. Oh, sorry, this was 2 OHs, 2 OHs to both sides. That would have been an easy mistake because there's 2 hydrogens, 2 OHs. Add up and simplify these water molecules. So you'll see that we have 3 water molecules on the left side, 1 water molecule on the right side. This one's going to go away, and this one's going to go away as well. Essentially, you're just going to have 2. So final equation is going to be 2 H2O liquid is going to give dihydrogen gas plus 2 hydronium aqueous, and I almost forgot. What the fuck was that? Oh, jeez. Sorry, guys. Ugh, that was horrible. 2 electrons. Now, we're going to type in our answer. Seems right. And we got it right.